Okay. Yeah, I have no idea. I'm just going to informally start writing on my board, and if anybody has any math questions, let me know. It's kind of hard to talk to the camera, so it's much easier if I know that somebody is listening and watching. And if they have any math questions, I'm happy to attempt to answer them. Oh, my circle is that's so annoying. When I look at this all the way out here, skewed. Here, I'm gonna fix it. I'll have to pretend like the camera's not there watching me. That way I don't get nervous. So think about what I want to write here. Get everything symmetrical. It's much easier to do this when I'm not nervous. So it's an added challenge. Try just, does that look better? Okay. It's not 100%, but spend an hour trying to figure out how to get the circle. It's okay, because I don't exactly have anybody asking me questions right now. Okay. All right. So we have measure of 1 degree. And let's see. All right. This is 90 degrees. We're thinking about the angles. And then, because the right angle is 90 degrees, and then we have 180 here. And then Adding 90 more, that's going to give me 270. And then we'll have 360. And radians. So we'll talk about radians. So let's see, how am I going to do this? Radian measure. So if you have 360 degrees in a circle, and the circumference right here is 2 pi r. So you have a circumference equals 2 pi r, and you have 360 degrees in a circle. So then if you solve this for r, dividing off the 2 pi from both sides, you get r equals 360 divided by 2 pi, which is going to reduce down to 180 over pi. And this leads to the unit conversion of a radian. So a radian measure is this conversion right here. So we have r equals 180 over pi. And this is how, you figure out the conversion between degrees and radians. So if I want to convert all of these degree measures to radians, then I would have degrees to radians. Spell it correctly. And you'll use that conversion, 180 degrees over pi, or depending on if you're going to degrees, you want the degrees on the bottom. So you would just flip it and say pi divided by 180. So this would be, if you want radians, hang on, I'm going to switch that. It's vice versa, like that. So let's try it. So we'll start with 90 degrees, and we want to figure out the radian measure of 90 degrees. Then we're just going to multiply it by this conversion. I want to make sure that the unit I'm ending up with is on the top in the numerator. Wait, did I just say that wrong? Did I get it backwards? Oh my gosh, I can't believe I just did that. Okay. So, hang on, maybe I didn't. 180. Let's try it. Okay, good. I didn't say it wrong, but I could have, because I make a lot of mistakes. All right, so this is going to be pi divided by 90 goes into 180 2 times. So this is going to be pi over 2 for 90 degrees. So it's 90 degrees, and it's also pi over 2. Okay. Okay. My minutes. Thought I did it wrong. It's been a while. All right. Let's try it again. We'll do it for 180, and this time it'll be a little bit easier. So we have pi over 2 for 90. And I'm gonna go ahead and leave that up there just in case. We'll erase it yet. So we got 180 degrees over 1, make a fraction. And then these conversions, they do get tricky. Sometimes you forget them. But you always want to make sure that whatever unit you're ending up with is going to be in your numerator, and then you probably won't mess it up. So I'm going to do 180 degrees and multiply by pi over 180 for my radian measure. And then the 180 degrees, they'll both cancel evenly because 180 divided by itself is just equal to 1. And then you end up with pi. So then over here, 180 degrees is also pi. Pi. We'll just put parentheses. And then we'll do that again for 270. So we have 270 degrees times my radian conversion, pi over 180. And then I got to figure out how many times, let's see, the zeros cancel, and then they're both divisible by 9. 27 is 9 times 3, and 18 is 9 times 2. So you end up with a 2 and a 3 there. And then so that's 3 pi over 2. And so 270 is otherwise known as 3 pi over 2 radians. And then we've got one more. Let's see if I can fit it in here. This one is going to be 360 degrees over 1 times pi over 180. Okay, and then we got 36 and 18. 18 times 2 is 36. So that is going to be 2 pi. And so we've got over here 360 is also 2 pi here. All right. So that is how you define the 4 quadrangles for the unit circle. I'm going to go ahead and erase this math because there's a lot more angles involved in the unit circle. So we have going to go ahead and erase all of this as well, because that was for, well, I'll erase my pi here. I'll erase that. Really, go ahead and erase this one as well. I want to go ahead and start talking about the triangles now. So the other part of the unit circle is the special triangles. Can also erase this. All right. So we have the special triangles. There's a right scaling triangle. It's a 30, 60, 90. And so we'll make this one a 30, 60, 90. And then the special relationship is 1 radical 3 is the hypotenuse of 2. Oh, can't see it. And then the other special triangle is that it's a right isosceles. And it has 2 equal sides. So it gives you a 45, 45. And the relationship of the sides is 1 to 1 to radical 2. And these triangles are basically how you derive the rest of the unit circle. Okay. What we're going to do is we'll take these two triangles and we're going to superimpose them onto this coordinate system, and we're going to figure out the degree measure and the radian measure for 30, 60, 45, and 45. So if I cut this in half right here, that looks like about a 45-degree angle. So we'll just say that 45 degrees is here. And then I'll try to do 15 less here and 15 more here. And that's going to give me my 30 and my 60. And then what I want to do is I want to find the 30-degree, 45-degree, and 60-degree counterparts for these other quadrants. So I do that. The first one would be the 30-degree. And so if I take 90, what I'm going to do is I'm going to come up from this side. So it's almost like it's a symmetrical thing. So I want to try and find 45 degrees here. So that looks about like 45. And then we'll start with the 45 counterpart. What I'm going to do is I'm going to add 45 degrees to 90. So 90 plus 45 is 135. So that, and I guess we need to start talking, I guess maybe back up and talk about an angle. Angles have, this is some formal teaching. I didn't have this whole lesson planned. I'm just winging it until I get more comfortable with the camera, and we'll see how this goes. Sorry. All right, so angles, or I guess the anatomy of an angle. They have a vertex, initial side, and a terminating side. So you have the initial side of an angle is where it starts. And it's moving in a counterclockwise motion. And then you have where it terminates is where it ends. Let's see if I can spell it right. And then you have the actual angle, the degree measure of the angle. A lot of times denoted as theta. Let's see if I can draw that. Okay, so when you're talking about these angles, your initial side is always going to be the x-axis. So when you're talking about a reference angle from this side, yes, you are measuring it this direction and it's technical, but the reference angle, we'll cover that later, talk a little more about it. So if I want to find the 60-degree counterpart here, what I'm going to do is we have try to see if we can draw it in here. 45 minus 15 will be about right in there, and greater than 15 will be right in there. And so I'm going to find the 30-degree counterpart by just adding 30 to 90. So 90 plus 30 is 110. And then we have plus 60. 90 plus 60 would be 150. Oops. 150 degrees. So that would be 30. So 180 minus 30 would be 50. So we have that 30-degree, 45, and your 60. And I'm going to try and write this one a little bit further here. 135. So it's right on that line from the 110. And then if you were going to split this up, then we would just repeat that process. You got your 45, and that would be your 30, and your 60. And so then 180 plus 30 is 210. 180 plus 45 is at 225. I don't have anybody to help me do the math, but darn it, I have to do it all in my head. And then let's see, 180 plus 225. Maybe I should get my calculator out and make sure I'm doing this right. I'm pretty sure that's right. Plus 45. Yeah, 225, and then I'll just say plus 15. That'll help me. And then we've got 240. And that checks out because 30 more would be 70. And then we have, we'll do it one more time for the fourth quadrant. And then show you. So 270 plus 30 is going to be 300. And then plus 15 more would be 315. And then plus 15 more would be 330. And so this is how the degree measures of how you would split the unit circle up. We can just take each one if you wanted to do it that way, and you could convert all of these like I showed you before using that radian measure conversion pi over 180, or you can use trigonometry. So what I want to do is I want to show you how to find all of these using these two special triangles and the trigonometric functions. So you have the special triangles, and then for right triangle geometry, you have trigonometry. So just for right triangles, you have the trig functions, sine, cosine, and tangent. We don't need tangent. We don't need tangent in this case. We're just going to use sine and cosine. The tangent one will come later. Sine is abbreviated as sin, and cosine is abbreviated as cos. And sine, by definition, is opposite over hypotenuse. And cosine, let's scoot it down a little bit more. Cosine. Get out of the way. I'm a lefty, so I can't really see what I'm writing. No one else can see what I'm writing either. That's a challenge. But you've got cosine, which is by definition is adjacent over hypotenuse. Okay. And these definitions, I'll go ahead and put that triangle in here. I didn't. So this is in, like everything is relative, so it's in relation to your reference angle. So for a angle theta, you have an opposite side. So this would be the opposite side of your reference angle. And then this side right here, right next to it, is adjacent to J. It'll be abbreviated AJ. And adjacent means next to. So it's the angle, it's the side next to the angle, be adjacent, and the side opposite your angle is the opposite side. The longest side in your triangle is always your hypotenuse. Okay, so that relationship is how they find these. So this is OPP over HYP for abbreviation, and ADJ over hypotenuse for your cosine. And we're going to be using this relationship, and we're going to derive the sine and cosine functions of these special triangles. And I have to remember to smile for the camera, because I'm not, I'm serious. Okay. So where's the best place to do that? I guess I'm going to start it here, and we'll just look at this first one. So for 30 degrees, you have your sine function, opposite over hypotenuse. So I'm going to go sine at 30 degrees equals, and I'm going to look here, 30 opposite over hypotenuse. So for 30 degrees, it's 1 over 2, 1/2. And yeah, we'll just need that. That'll be in the way. We'll go ahead and back up and put the cosine up here. Do cosine first. Cosine 30 degrees. Cosine by definition is adjacent over hypotenuse. So looking at the 30-degree reference angle, adjacent to 30 degrees would be radical 2, or sorry, radical 3 rather. And it would be over your hypotenuse here by the definition. So we'll put over 2. So we found for 30 degrees sine and cosine, we need to go ahead and find the sine and the cosine for 45. So we'll do that. Maybe I'll have room here. So we'll do cosine of 45 degrees. And we'll go over here to 45 degrees. The cosine is adjacent over hypotenuse. So it's going to be 1 over radical 2. You're not allowed to have radicals in the denominator, so I'll have to rationalize this. This one becomes radical 2 over 2. And if you need to know how to rationalize denominators and how I figured that out, let me know. And I'll do a little side explanation there for that. Go ahead and box these because I'm going to need it to put in my unit circle. And I need to see if I have room down here for the sine of 45. And that is sine of 45 by definition is opposite over hypotenuse, which is 1 over radical 2. And that is also going to reduce down to radical 2 over 2. Just rationalizing the denominator, removing the radical from it. Not changing the value, just making it a little bit more user-friendly. All right, so we have 430 degrees. We have this coordinate right here. We have the cosine. I guess I need to explain that. So for the unit circle, we might try to explain this again, see if I do better next time. This, so we have this circle that is lying on the Cartesian coordinate system with all these points showing up. And one of the beauties of the unit circle and the usefulness of it is that if we ever need to know the location of these points, then you have an x component and a y component. So order pairs. So you can calculate the order pairs. So you use the equation cosine theta equals x and sine theta equal y. And so it leads to the cosine of theta corresponding to your x component and sine theta corresponding to y as an order pair. So right here for 30 degrees, if I want to know the location of this point, I already have it according to the cosine. It's radical 3 over 2, comma 1/2. And for 45 degrees, it's going to be radical 2 over 2, radical 2 over 2. And for 60 degrees, we didn't calculate 60, we'll do real quick. Cosine of 60 degrees is going to be, so we're looking at 60 now for our reference angle. Cosine is adjacent over hypotenuse, so that's going to give me 1/2. And the sine of 60 degrees is going to be opposite over hypotenuse. So that's going to be radical 3 over 2. And so then we've got this value right here. These are order pairs we know. So that's radical 3. Oops, messing it up. Cosine is your x and sine is your y. So that is going to be 1/2, comma, radical 3 over 2 for your y. And then since you already know these, then you already know the location of these points as well, because it's a unit circle. So it's symmetrical in every way. And all you need to do now is change the signs of these values. So what happens is you have these quadrants. So you have quadrant 1, where your X and your Y are both positive. And you have quadrant 2, where your X value is negative, but your Y values are all positive in quadrant 2. And then quadrant 3 down here, you have both values, X and Y are both negative. And then you have quadrant 4, where you have your X values are positive, but your Y values are negative. And so all I'm going to do is I'm going to take these values and I'm going to flip them. So it's a symmetrical thing, and you're always going to take from your the x-axis whenever you're doing your reference angles. So 150 is going to correspond with 30 degrees. So this point right here is going to be, now all you're going to do is switch the sign of your x, and your y is still going to be positive. So this becomes negative radical 3 over 2, comma 1/2. And then this one for 45 degrees, your x values are, it's identical. Only thing you're switching is the sign on your x value. Equal 2 over 2. And then this one would be negative 1/2 radical 3, 2. And then you would just repeat that process for all of these. So let's see if I can do it again. So this one, they're both going to be negative now. So this is going to be your reference angle, 30 degrees, 45, and then 60. So this one is going to correspond with your 30 degrees. So that's going to be radical 3 over 2, comma, negative 1/2. Just remember changing the signs only. This one is negative radical 2 over 2, negative radical 2 over 2. How does this happen? Really? Okay. So do a better job painting that little nice light strip or something. I'll fix it later. All right. And then also that looked a little sloppy, so fix it. Let's see. Where was I? Startled me. 240 here. This is going to correspond with the 60 degree, negative 1/2, negative radical 3 over 2. And then this one right here is going to correspond, that will be, well, this one's going to be your 30 degree reference angle right here. So this one is the one that's corresponding with 30 degrees. And the x value is going to be positive, and your y value is going to be switched here because of quadrant 4. So that'll be negative 1/2. And this is your 40. I think the 45 is pretty, well, it's the easier one to remember because it's right in the middle. If you're having a hard time remembering, just remember you're always dropping that reference angle from your x-axis, and that might help. And so this one is going to be positive radical 2 over 2, comma, negative radical 2 over 2. That was really challenging. I got one more. Try and get this a little bit lower right here. 3 pi over 2. This one is 1/2, comma, negative radical 3 over 2. And not too bad for my first time trying it out on the board. It's very challenging. The only other thing I wanted to do to discipline myself was to convert these angles. So we still have to find the radian measure for all of these angles here. And there's a shortcut to do it, kind of, but it just boils down to that radian conversion. What time is it? There it is. Oh, it's after 7 already. Well, I don't know what time I got started. I got started a little late, so maybe I'll go a little bit longer. I was just trying to go from 6 to 7. Try and keep it just an hour for now until I get a little bit more comfortable. I get people helping me. Yeah, it doesn't look too bad. I'll go ahead and finish filling up the board and go ahead and start doing these conversions. So for 30 degrees, if I want to know, let's see, if I want to convert 30 degrees to radians, then I'm going to multiply it by pi over 180. And then I'm going to reduce it down. So if those zeros cancel and 3 goes into 18, 3 times 6 is 18. So that's going to drop down and I'm going to have a 6 here. So that's pi over 6. So 30 degrees becomes pi over 6. And then 45 degrees over 1 times pi over 180. And 4 times 2 is 90, and 90 times 2 is 180. So that becomes pi over 4. And 45 goes into 180 4 times. So pi over 4, get that in there. And now I've got 60 degrees. 60 degrees. Ooh, I can't write upside down and get there. 60 degrees over 1 times pi over 180. Can you see that? And so that is 6 goes into 18 3 times. So that becomes pi over 3. And then we will just repeat that process for all the other ones. Or you could add 90 degrees to each one because we're just going over 90, up 90. So if you wanted to add a pi over 2, you could add fractions. Multiplying fractions is typically easier than adding. So let's go ahead and just do a couple more and then we'll stop. So we've got 110 over 1 times pi over 180. And that's not going to reduce down. It's going to be 11 pi over 18. So we're just putting 110 is 11 pi over 18. And then, wait, that's not right. 110, 90 plus 30 is 110. It's 120. I was like, that does not look right to me. 120. How did I mess that up? And you know that is a simple mistake that that's nerves for me. All right, let me try that again. I was like 110. All right, 120 over 1 times pi over 180. It's been too long since I've done the math. I need to get back into it. And then 12 and 18 will actually reduce down. 12, let's see. They both go into 6, so that's going to be 2 and 3. So 2 pi over 3 sounds a lot better. So we'll say that's 2 pi over 3. All right, I cannot believe that is a new low. I'm silly. All right, 135. 135, and see if I can get out of the way. Over 1 times pi over 180. And this one, I know they both go into 5. So if you're struggling to break them down, we'll just break it down. 135 divided by 5. They both go into 5. It's 27. So we got 27 pi over 180 divided by 5, 36. And that's going to reduce down a little bit. So then they both go into 9. So 9 times 3. So you've got 3 and 9 times 4. So that's 3 pi over 4. 3 pi over 4. And then we'll do 150 in here somewhere. 150 degrees over 1 times pi over 180. So those cancel, and I've got 15 and 18. They're both divisible by 3. That's 5 and 6. So that gives you 5 pi over 6 for 150 degrees. All right. So we've got halfway around that circle, and it's getting pretty muddy. Let's see. Did I make it exactly an hour? I was trying to go, I only got 47 minutes. So what I'm going to do is I'm going to go ahead and finish doing that for the bottom half of this circle. That way I can get a full hour in. I feel like that will be sufficient for my first day. All right, good. I'm going to have to erase some stuff. So maybe I'll erase all of this. Hopefully, after I get used to learning on this board, maybe I'll get more organized. Can only help. That triangle either. It's a little bit better. All right. So go ahead and do the other for the other half of the circle. So we'll take this 210. So 210 degrees times pi over 180. And so we're just going to multiply these. 210, so that's going to give me 21 pi over 18. And then I'm just reducing these fractions down. Maybe I should go ahead and take show you, because I'm doing that kind of fast. Maybe I should show you how I'm breaking these down. So all I'm doing is, I'm doing it in my head, but the process is to break it down into its prime factorization, both numbers in your numerator and your denominator. And then you cancel out using the fact that anything divided by itself is equal to 1. You make cancellations. So like if I want to take 210 and figure out its unique prime factorization, then I'll start like a factor tree, and I start splitting it up. 210 divided by 2, because it's even. So divided by 2 is going to be 105. Yeah, 105 times 2, and then it's divisible by 5. Is 21. So you've got 5 times 2 times 21. And then 21 was that 7 times 3? So then 210 equals, let me erase this. 210's factorization is 2 times 3 times 5 times 7. So if I multiply all those numbers together, it's going to give me 210. Let's try it. 2 times 5 times 3 times 7. Yeah, 210. And then I'll do the same thing for 180. So 180's unique prime factorization. Well, I know half of it's 90, so that's 2 times 90. And then that's divided by, or do it divided by 5 or 3 first. 90 divided by 3. So that's 2 times 3 times 30. So that's 2 times 3 times 3 times 10. And that is 2 times 3 times 3 times 2 times 5. So I found 180 to be 2 times 2 times 3 times 3 times 5. And we'll check it. 2 times 2 times 3 times 3 times 5. And it's giving me 180. So if I want to reduce 210 over 1 times pi over 180, that's going to give me, I'm just multiplying fractions, it's going to give me 210 pi over 180. So that is going to give me, that becomes 2 times 3 times 5 times 7 times pi divided by 2 times 2 times 3 times 3 times 5. And since anything divided by itself is equal to the quantity of 1, then you can cancel out any factors that are in common. We got 5 as well. So then what's left in the numerator just becomes your new fraction. So you have a 2 and 7. So this becomes 7 pi over 2. And that's your radian measure for 210 degrees, 7 pi over 2. So we'll spend a little bit more time in the third quadrant going ahead and breaking these numbers into the unique factorization, because I think that it's relevant, and students probably, especially if you're struggling to reduce fractions, this will be good for you. So we're going to do it for the conversion to radians for 225. So we've got 225 degrees times pi over 180. And we'll start with the prime factorization of 225. It ends in 5, so I know that it reduces down, or it divides 5. So that's 225. That's 45. So that's going to be 3 times 3 times 5 times 5. I think that's 225. Yeah. And then we'll do the same thing for 180. See if I can remember it from the previous, because I already erased it. That was 2 times 2 times 3 times 3. That's 9 times 4. No, I don't remember it. Hang on. 180 divided by 5 is 36. Okay, I got it. So that's right. So 3 times 3 is 9, times 4 is 36, times 5. That was close. So we've got 3 times 3 times 5 times 5 times pi over 2 times 2 times 3 times 3 times 5. And then we'll just cancel out the 3's, more of the 5's. The 2's are going to stay, and the 5 pi is going to stay. So that's going to give me 5 pi over 4. So 225 is 5 pi over 4. If you get bored of converting this way, at any point, you're welcome to switch and just start adding fractions. So let me show you how to do that next. Like, if I'm at 5 pi over 4, and I just want to add 15 degrees, then I can find the radian conversion of 15, or I can go back to if you see here, 30 degrees is pi over 6, and this is just an alternate method of finding these angles. You can actually add the radian measure fractions and find them that way. So I just thought about this. So say I'm at 210, or I want to figure out what the radian measure of 240 is, then 210, do you see the difference between 210 and 40 is just 30 degrees? So I can take my 7 pi over 2 here, I already found 7 pi over 2, and I can add pi over 6 to that number. And it's going to give me the radian measure. So we'll find it this way, and then we'll turn around and we'll check it the other way. How about that? So 7 pi over 2 plus a pi over 6. And this will be a good refresher on how to add fractions. So what you're doing is you're making equivalent fractions. So you're getting a common denominator. So the common denominator between 2 and 6 is the smallest number that divides both of these numbers evenly. And so it's going to have to be 6, right? So I'm figuring the number 2 times 3 is 6. So I'm going to multiply 7 times 3 times pi. And I'm going to add that. This is already a 6, so this just becomes pi. So 7 times 3 is 21. So 21 pi plus pi over 6 is going to give me 22 pi over 6. And then we would have to reduce that fraction. So they both divide 2 evenly, so we'll divide a 2 out of both these numbers. That's going to give me 11 pi over 3. Oops. Hang on. 11 pi over 3. So there's an alternate way of finding those other degree measures. And so then you could check it. You could add 15 degrees, or you could add 30 from 225 to check and see if you get 3 pi over 2. 3 pi over 2. But more importantly, we're going to go to 300. So I'll put them, I guess I could put them over here. 300 degrees. 300 over 1 times pi over 180. So I guess you can let me know if which way you find easier. You want to just add fractions, or you could convert and multiply this way. So 3 goes into 30 10 times, so that's 10 pi. And 3 goes into 18 9 times. No, sorry, 6. My fault. And then half of 10 is 5 pi, and half of 6 is 3. So you end up with a 5 pi over 3 for 300. And you can also, let's see, 40 to, from 40 to 300 is 60 degrees. So an alternate way to find that angle would be take your 11 pi over 3 and add 60 degrees would be pi over 3. So let's do it that alternate way. So we'll say 240, which is 11 pi over 3. And I'm going to add that to, because see how it's already in the denominator? And I'm adding 60, then I don't have to convert. All I have to do, since they already have the common denominator, I can say that's 12 pi. Because if you have 11 pi and you add pi to it, that gives you 12 pi over 3. And then that reduces down. And wait a second, that is not right. What did I do wrong? There's no way. Hang on, the math is wrong. 11 pi over 3. See, that is the trashing of doing math by myself. Okay, that is, let me multiply that, make sure that that's a conversion. See, it's dangerous when I'm doing math by myself. $240. That's right, isn't it? Yeah, 240 over pi over 3. Oh, duh. Well, pi over 3 plus 60. Oh, it's 11. Hang on. 11 pi. Yeah. I don't know where I'm stuck. Right, so we're just going to do it this way, because this is 5 pi over 3, not 11. Why am I getting stuck here? Okay, 30. We should get 5 pi over 3. Why am I only getting 4 pi over 3? Let me try it one time. So 11 pi over 3 plus pi over 3. That's going to give me 12 pi over 3. And 12 divided by 3 is 4 pi. That's not right. There's no way. I don't know what I'm doing wrong. Okay, it's all right. Let's move on. And then 240. 315 over 1 times pi over 180. And I'll try and figure out what it was that I was doing wrong. Oh, I'm already over an hour. Look at me. Good. Let me finish and then we'll end it. Let's see, 315 to 180. That's a harder one to convert. So then you just have to start dividing out for 5. So I know they're both divisible by 5. So we'll do 315 divided by 5. We got 63. And then it's 36. So those are both factors of 9. So that's 7. 63 is 7 times 9 is 63. And then 9 times 4. So that I'm getting 7 pi over 4 for 315. 7 pi over 4. And then we'll do one more, 330 over 1 times pi over 180. So we've got 33 pi over 18. They both divide out to 3, so that's going to be 11 pi over 6. 11 pi over 6, does that sound right? And then what I really want to do is pull up a unit circle and check my math and see how I did. Let me look it up real quick and then we'll end it. All right. Let's see. I can't really see it that close. How do you make the screen bigger? It's in the way. All right, so I can't really see this small. This looks like a bigger one. And then it's like they do that on purpose. That I don't want you getting a good picture of it or something. All right, so we've got 11 pi over 6, 7 pi over 4. Yeah, looks like I did good. 5 pi over 3. Yeah, all right, good. I don't really see any mistakes, but it could happen. It's easy to do. So, all right, I'm gonna go ahead and end for now. And yeah, we'll see you all again tomorrow.